Hi, my name's Jorn. You can see on the screen. I'm from the SUSE Cloud Container Solutions Center of Excellence. I focus a lot on Kubernetes security, which is what we'll be talking about today. Kubernetes is kind of a wild and confusing topic that a lot of people don't know about, and security is a wild and confusing topic that not a lot of people know about. So buckle in. We're going to try to have a little bit of fun. I'm also going to try not to PowerPoint you to death, as we say. I do need to have some pictures. I would go to the whiteboard and draw them for you, but my artistic skills are not fit for public consumption. So I'm going to set up a scenario, and then we're actually going to go, to the console, do some nerdy stuff. I hope you find this valuable and enjoyable. And I've always got to remember, as we should with any sort of presentation, a talk, training, whether it's just one-on-one or in front of an audience of thousands, or when we're trying to train people, is what problem are we solving? And the problem that we're trying to solve today, and I'll show that to you, is trying to get some runtime zero trust kind of controls inside of an AKS and other Kubernetes clusters without breaking things, right? I don't want to say, open firewall rules and open a ticket, because that breaks agility and we're not going to do it at all. And we're going to keep that in mind. So I want to make sure that things are extremely practical as we go along. So what problem are we solving, right? And what we're trying to do is address from a security standpoint that old school security solutions and practices really don't make sense inside of a container environment, inside of a Kubernetes environment. And for purposes of this talk, I'm going to be using Kubernetes very much like a pronoun, right? It's a container environment. It could be AKS or Kubernetes the hard way on your laptop if you're so inclined. But the thing that we're trying to address, and because of those older solutions, is they don't understand the context of container sprawl, right? I mean, you talk about the explosive growth of sort of shadow IT of VMs. Well, containers are everywhere. They come up, they go down, the entire lifecycle process, in fact, of a container is that it should be immutable but ephemeral, and you build it, you run it, you destroy and create again. So it's very hard to say that machine over there, or even that IP address, or this thing on that node. So that makes other solutions hard. The other thing that makes it even harder, and this is actually a very big deal, right? When we were starting to deploy in container environments as a developer, it's infrastructure as code, networking's kind of hard, right? So the good news is the network is flat and everybody can just talk to each other and it just works. And if you're a network or security or operations person, you're like, that's dreadful. The network is just flat and I can't see it and everybody can just talk to each other. And that's when we get into the situations about security boundaries, right? The inside of a Kubernetes cluster, we're all friends here and everything's okay. And then we'll treat that perimeter as the security boundary. Because, and I think you'll agree if you think about this one for a while, Kubernetes is kind of a data center and a data center. So what should we do? Well, here are some things we could try to do, or at least some objectives inside of the environment. What we really want to do is try to treat each and every container or pod as its own security boundary. Each application has its own security boundary. And we do that by way of explicitly defining what an application, the whole stack, ought to do, what we think is good, and then explicitly alerting on or denying anything outside of that. Right? A good example of the contrast between that kind of zero trust and just doing threat-based controls like CVEs or virus scanners and the like would be, say, a bank. Right? If I were one of the top 10 most wanted bank robbers in the world, they'd have a list and I would be on it and my name would be on it and I would not be allowed in any banks. But on the flip side, let's pretend I'm not the bank robber anymore. Think of your checking account. My name is not on your checking account. At least it ought not be. So how do I not steal your money? Well, your name is on it, explicitly defined as the person who can touch it. And we implicitly understand that we should deny anybody else from touching it. That's zero trust. Zero trust is the antithesis of this implied we're all friends here on any given level. Explicitly yes, anything else is implicitly no. But again, if we want to do security like that inside of Kubernetes, we need to automate all of those things just like you do when you're doing infrastructure as code, your GitOps, the whole thing. And back to that layer 7 thing, I'm going to talk about layer 7. I'm going to talk about the network quite a bit here. The network is important. That's where attacks happen. If you're going to do a container escape, you're escaping onto the network to talk to another container. That's how threats get in and vulnerabilities are exposed. And layer 7, that top layer of the OSI model, is extremely important. That's where the protocol is defined. We can't just go out there and go, well, it's port 53. I'm sure it's DNS, because nobody would do bad things on the internet. And like I talked about earlier, that threat, that risk-based thing, let's not get caught up in this, well, we're going to just try to patch everything kind of philosophy. Definitely patch your software. Like, don't not do that. But one of the challenges with a purely chasing CVEs and patching our software philosophy is, one, you need to be perfect at it. And let's say you are. I mean, you are. Other people aren't, but you are. You're perfect at patching, right? There are things like vulnerabilities that don't have a patch. You may not get around it. Oh, no, we established you always patch. And there might be things that aren't known yet. Those are called 0 days. We need to try to protect against those. And we need to leverage all those abstractions inside of an environment to make it work. So let's talk a little bit about the network now that you're convinced, or I hope you're convinced, that the network really, really matters. So here's another okay drawing. Like, engineers we don't have graphic artists drawing things, so don't point at my pictures and laugh, please, or go ahead. So let's take my little, kind of Kubernetes cluster. I got a couple of pods and there's containers inside them. One of the big challenges is that you cannot see the network traffic. I can't see real-time network traffic inside of a Kubernetes cluster. There are some tools going to alert me to things after the fact. I can certainly set up IP tables, but that ability to go, what's happening on the wire, again, like we established earlier, is obfuscated and really, really gone, especially the whole stack. You can, of course, see some things north-south because I've got ingress and egress controllers, but I lack visibility from outside of there. Right? Well, let's get to the point. So years ago, 7 or 8 years ago, the inventors of NeuVector, which is now part of the SUSE family, created an patented approach to be able to see the network in a Kubernetes cluster and the whole OSI stack. Cool, magical. It's really actually a lot of fun, and there's a reason that it's patented, because I was told it's, quote, very, very hard. And so now you've got that ability to go in, look at what an application is doing on the wire from a process standpoint, and even give you the power, should you choose to use it in different parts of the environment, to actually go in and block certain bad things, right? We could either alert against them or block them on the wire, which is kind of a good thing to do inside of security. And that can be very, very granular. So what does that give you, right? That deep packet inspection gives you right away visibility inside of your Kubernetes environment you didn't have before. Survey after survey about C-level executives and security people are like, we want more visibility. You could get that here. You could see the behavior of an application inside of your Kubernetes environment like you couldn't before. But what power does that give us? Well, now you have the ability to sort of fingerprint the behavior of an application in an application stack. And then we can auto-generate that policy. Now I'm getting the explicit definition of what is good, right? See where we're going here, and anything that's not on the list of good things is bad. And you can auto-generate that security policy. Down to the next bullet point, you could do security as code, which I'm actually going to show you in a couple of minutes. And that gives you those protections against, unpatched, 0 days, and you get even a little more strength against, like, say you're doing, you're subject to compliance things like SOC 2 or PCI DSS, where they might want to say, do you have data loss prevention? Can I look for patterns in the payload to alert or prevent them? Yes. You also get the ability to do honest-to-goodness packet capture inside of a Kubernetes policy. So I'm going to run off and do a little bit of a demo, or a lot of bit of a demo, right? And what we're going to do is try to show you something that's actually pretty practical in real-world use. That is the SDLC, the lifecycle of an application, your application, whatever it may be. And for demonstration's sakes, we're going to use a bit of an assumption that there is this sort of 3 cycles, or maybe 2, right? Of course, you dev test your software somewhere, and there is that state. You may do a QA process to test the test, to prove it, and then you've got production. As a general practice, that's pretty good. And as a general practice in Kubernetes, again, your environment may vary, but we try to use these in distinct clusters. And that's what I'm going to show you today. Clearly, I'm going to be using some AKS clusters, but I need an application to run through, right? So I'm going to put NeuVector on each and every one of my clusters to watch what the application is doing. And we're going to sort of profile those. We're going to test that. And then we are going to see how we can do some enforcement with Zero Trust. So here comes my application. And the application I've chose for my multi-factor app is WordPress, right? Pretty simple. It's two factors, front end and back end, but that's a great example of an application stack. It's well known. Everybody's using it on the internet. And let's go do a live demo, right? So I'm going to hop off to my console here. I've got a couple of clusters. They're aptly named Dev and QA and production, so we'll be able to keep up. And I do have NeuVector installed inside of this environment. In fact, let's go get the pods and the services inside of that NeuVector namespace. See, live demoing, we have to make sure we type our commands correctly. And let's fire that off. And the reason I'm doing this now is I want to show you, here are the things that make NeuVector run. It's completely Kubernetes native, which is wonderful. You don't need to, sign up to talk to a sales organization for an hour to get a license key for 30 minutes and have people email. You can just go ahead and use it. And the other thing I wanted to show you is I was actually, for my purposes, our demo, I do have the web user interface sitting out there at a load balancer publicly. So what I'm actually going to do is I'm going to grab this IP address, hop on over to my browser, and we've put that here. And I've got a nice login I can use. Clearly I've been here because I prepared for my demo. And I'm now logged into the NeuVector interface on my dev environment. I'm going to give you a quick tour of some important parts of the interface and the things we're going to focus on. So, naturally I can see all the assets inside of here. You can see that I'm sitting on a nice AKS cluster. I've got some of the namespaces that are created. It's your garden variety. If you type, AKS Cuddle, you get a nice 3-node beautiful cluster. Thank you, Microsoft. That makes it very, very easy. And I've got the system components that I've got inside of my environment. Right out of the gate, I'm able to do things like see some of my security risks. Remember, we're talking about vulnerabilities. I can see all the vulns in my environment, the impact of them. What's fun here is this is I built it just now, garden variety out of the gate AKS cluster. And there's no other software running here other than NeuVector at this moment. And we've got some vulnerabilities, right? I could even, filter down on some that don't have a fix. So, there's our, hey, we've patched everything. Well, you've patched everything you can. But that's not the point I want to show you today. Where I want to show you again is that flex of being able to do zero trust and being able to do it very, very quickly inside of your environment. So I'm going to go right straight to this place inside of the interface under policy and under groups. What's cool about groups? Groups are automatically created via NeuVector inside of the interface based upon your deployment. The deployment and the namespace that they're in. And what's great about groups is it gives the ability to, anytime something comes up in the environments, containers come and go, they'll always be a member of a group. And now we can apply security policies to that group. I can go look and see what the learned network rules are, right? This whole time I was talking, things were happening inside of this Kubernetes cluster, and I can see that, of course, the core DNS, talk to the outside world. The outside world, talk to core DNS, because that's what this is. I can see the processes that were run on it. Clearly, I've got an autoscaler, pause as part of Kubernetes, but and these are core services, so they're not very exciting. This becomes more exciting when we actually put an application in our environment. And I promised the very exciting WordPress would be rolling along. So let's do that in real time here. So I'm going to install WordPress just from an online Helm chart, and away we go. Right, so Helm is beginning to install the WordPress inside of my environment. Clearly, I built the namespace. In fact, what we can do is go get those pods from the namespace WordPress, and this takes a couple minutes to come up, and just to prove that we're doing this in real time, we'll give that a little bit of a watch. And I'm actually going to go back to my cute little graphics I had before, because I do want to explain something that we're about to see inside of this environment. And that's what you see in my little arrows. I've got this profile, test, and enforce. We're going to go into what's called discover, monitor, and protect. And what do those mean? So there's 3 modes that any group can be in, not the entire cluster, because that would be annoying, but any group can be in any one of these modes. And NeuVector lands by default in what's called discover mode. Discover mode does what the name implies. It discovers and watches those processes and those network connections, just like I was talking about, and builds a fingerprint of that application stack as a definition of what's good, right? Can you manually add those? Sure. Can you manually delete them? Like, that's crazy, get rid of that. Of course you can, but that builds that profile for you. And you would probably do that, in our example, in the dev test part of your application, right? So if you're hearing what I'm saying is there's no extra that you're going to have to add to your workload. Like, I need 3 people to run this stuff. No, you don't. Let NeuVector just profile the application while you're testing it and move on with your life. The next mode that things can be in is what's called monitor mode. In monitor mode, NeuVector stops learning and will then take that fingerprint, that profile that we established, and it will alert you to anything that was not explicitly defined as good, which is then implicitly defined as bad, and say, hey, this thing tried to happen. A process that you hadn't defined as good tried to run. A network connection ran. It might even be a network connection that was defined as okay between 2 different containers, but it was a different protocol this time, or it went to a different network. And the third mode that we can run, and you've probably already thought ahead of me, good for you, you're smart, is protect mode. Protect mode is much like monitor. In fact, if you think of monitor as a dry run against what protect mode does, protect mode will say, hey, this thing was attempted and I stopped it. Right? And you can run that in any given group that you want. You could enforce it all over the place. You could run it fully in protect mode of production, or depending upon the social culture of your organization, maybe you want to have some things and just monitor and alert them in your SIM, or all of them. You do you. Anyway, that's the story, and I'm sticking to it. Let's go back and see if our WordPress deployed. Oh my goodness, it did. See, I wasn't just wasting time, I was burning time. So what I'm going to do is I'm going to get the services out of WordPress, because that'll give me, there it is. Oh, look, there's my external IP address. Let's just go look at our WordPress installation. And one of the reasons I want to do that is I want to just exercise the app a little bit. Like, that's what dev test does. Like, look, here's a WordPress site. And let's go back to NeuVector. Remember, we were trolling around inside of this groups. I'm going to hit refresh and show you something fun. Right when that was installing, I wound up here with this new groups created. In fact, I'm going to filter it down so as not to be a distraction to myself. Certainly not you. You don't get distracted. I've got 2 groups representing WordPress, the front end, and the back end. And as you can see here, if I click on that WordPress group, I've got all of these process profile rules. These are all the processes that just now were witnessed running on that container to make this environment run. And I could go, for example, look at the network rules. Again, look at these connections. I've got WordPress talking to Core DNS. Of course, I have the front end talking to the back end, MariaDB. That makes sense. But this is when I started touching these things, you'll see just a moment ago, they came up. And the other thing I could do is go look at the back end. Now, here's something I want to point out, right? The process profile rules, it's got some normal things that are running. For example, I could get rid of bash if I don't want people shelling into containers and trying to fix them. Remember that one. But the other thing that I think is really interesting here, and what it does is it answers a profoundly popular question. And that's, Jorn, how long should I leave things in discover mode? And I told you earlier, maybe why don't you just follow that dev test cycle? Well, here's something out of that dev test cycle that I think is very interesting. Behold, the front end is talking to the back end using the MySQL protocol. Should anything else ever happen here? I don't think so. You could certainly pop this group into monitor mode, right? So if anything else does happen, you could get alerted inside of the NeuVector console and certainly plugged into your SIM, whether it's Datadog or any of the others, or any alert system that you've got, that something went wrong here. Or maybe, if this winds up being production, you could switch it into protect mode. But here's something that's I think is really fun. Remember, we were talking about this lifecycle, these different clusters. Did I build a cluster for QA? Of course I did. Let's go look at that QA cluster. So I'm going to change my context now here. And I've got some shortcuts on my screen. Obviously, I'm changing my context to this this QA cluster that I built. Ooh, QA. I have to make sure I'm correctly typing things because I don't trust my my spelling. So I'm in that build QA. I do not have WordPress installed in this cluster, right? Nothing else is here. I can go log into, so let's go look at the NeuVector console for my QA cluster. I'll log back in. You can see up here in the top, build QA is in. I go look at my policy and groups because that's where work gets done in NeuVector. And you'll see I don't have those WordPress groups existing. Back to my dev test cluster where I learned these processes, my response rules, the whole works. I'm going to grab onto both of these groups and I'm going to export the group policy out of this. So here's where security as code comes in. And yes, you could drive this whole thing from the API. And you'll see this little drop-down list here. And this drop-down list is actually telling me what way could assert the group mode will be in, right? Leave it the way it is, or should I universally assert that maybe they're all in monitor mode? I'm going to do that because I'm sending it over to my QA cluster to test to see if the rules I wrote were any good. So let's do that. Behold, and let's turn up the font on this a little bit so we can all read it on the screen. We have YAML. YAML, the language of the gods, right? We're all very familiar with it. I look at it, it's a YAML. In fact, this is actually a CRD, a custom resource definition, that allows applications like NeuVector and all the others to extend the capabilities of Kubernetes. And there are several things we can do with it. The main thing I'm going to show you, but the first thing we can do, or what happens, is what's happening now. We're looking at this, and we're rubbing our chins in great pontification and knowledge and looking smart. What this is a YAML-defined list of all of the behavior that NeuVector saw that tells you what happened in this application. You could take it and go, is this right? You could certainly change this file. And if you're thinking, hey, can I check this into a GitOps process? Yes, you could. If you're a security admin, you could take this and give it to your application developers. Go, look, I wrote the security policies for you. Cool, huh? Maybe you'll get a piece of pizza. Wouldn't that be nice? But the other thing that it allows us to do is I'm going to go back to my console. Remember, my context is pointed at my QA cluster. So I'm just going to do a Kubernetes, or kubectl apply that file, and it starts with CFG. That file we just looked at, right? This, the one we were all feeling very smart about. I'm going to apply it to my QA cluster. Two of them, right? We created these things, and now I'm going to go back over to my interface, and I'm going to do a little bit of refresh, again, in my groups on my QA cluster. Keep up. And you'll notice that it looks like I exported the wrong one. So I now have the security policies for this application in my QA cluster. Before the application's even here, it's waiting for WordPress to arrive. The other thing that's cool about this, and two things I want to point out beyond the obvious visual effect that it says CRD on it, my rules are here, my network rules are here. Remember, my MariaDB, front, back, it's in monitor mode. We're testing to see this. CRD rules are matched first from a rule standpoint. So if you had rules that you had learned in this environment, and there was a conflict, CRD rules get hit first and then exited. The other thing that's important is that as the administrator, even in this environment, I don't have the ability to edit these CRD rules in the GUI. We have to go back through that apply from a Kubernetes kubectl standpoint because that keeps the whole process intact, right? Hey, check it back in GitOps, move it back and forth. Extremely handy. And that's security as code. And let's say everything went great here, or maybe I wound up getting an alert, a security risk, and an alert inside of my environment that said, oh, there was a connection, admin was running on this. So this is an alert inside of this environment. Remember, I threw it into monitor mode and I'm in the security events. I could look at this and go, wow, what is this? Am I under some sort of attack? Or did I miss adding a rule when we were in discover mode? We don't have to go back to discover mode and start all over again and eat another sandwich and watch. I could review this rule and say, hey, that's okay. This definitely should be running inside of this environment. And I've now added that rule to my explicit allow list inside of this environment. So that's my show. I'm glad you attended. We only had a certain amount of time. I want to let you know what I think the takeaways really ought to be for you, right? So Kubernetes security should be Kubernetes native. NeuVector installs and runs in a very Kubernetes native way, but it also operates in a container-aware Kubernetes way. It understands that environments are dynamic. Containers come and go, and it doesn't really get into your way. And also, understanding the entire network is extremely critical. We need to know what that protocol is. We need to know what's happening on the network, because again, that's where attacks happen and traverse. I put a little bullet point in here about auditors are sort of behind. I've seen some auditors who are really strict about the entire environment, and they're like, oh, you've got things running in Kubernetes, I'm sure it's fine. Auditors are catching up. So if you're subject to any sort of acronyms coming down from above, if you've gotten away with, things inside of Kubernetes, those days are probably coming to the end. Shrink that security boundary. Do zero trust across and inside of your application workloads, right down to containers. You can see it's actually pretty straightforward. It's unobtrusive. You don't need to hire a bunch of people to get that work done. And my last little shout out is NeuVector is open source. Try it, play with it, have it as part of your toolkit. Do not fall under that false idea that one interface or one tool to rule them all. You know that doesn't exist. Even if you have other security tools in your environment, take the parts that NeuVector is fantastic and important at and have it in your environment. Spread around, show people, ask us some questions. And that really ends it, right? And of course, we'll be able to have this up and running inside of AKS, inside of your Microsoft environment as just a button push. That's coming up in June, so keep an eye out for that. And again, I thank you for your time. I appreciate you being here. And if you happen to come by the booth live at Microsoft Build, I will be here probably talking just as fast as I did now.